Have you ever wondered how Netflix knows which program you want to watch next? Or how stock markets are able to predict future prices? In this tutorial, I'm going to show you how to build one such algorithm, a linear regression algorithm. And we'll build this algorithm from scratch with vanilla JavaScript. So let's get coding. Okay, so let's open up our favorite editor. Mine is Visual Studio Code. I've got just an empty project open here with a terminal at the bottom. The first thing we want to do is create a new file. So I'm going to create index.js. The first thing we want to do is create a data set. So I'm going to have a data set of x and y. X being the independent variables, which is the input, and y being the dependent variables, which is the output. So we'll create two constants. X is equal to, and we'll just have 1, 2, 3, 4, and 5 in here. And then const y will be equal to, and these numbers will be slightly different. We'll go 3, 4, 2, 3, and 5. And that's the data for the input and the output. So with these data inputs, for example, this would be, X would be your days and Y would be your closing stock prices, or X could be your days of the year and Y be your average temperatures. For stuff like marketing, X could be days since launch and Y could be the number of visitors, and so on. So we can build that up and you can turn this into whatever you want. But for now, we're just going to use these arbitrary values. So up next, we're going to create a utility function. This is going to be a mean function. So we're going to call function and then mean, and that's going to take in an array. What we want to do is we want to return the array dot reduce. That's going to have the accumulator parameters and the value parameter. And then from there, what we want to do is add the accumulator to the value, and then we're going to not make this read only, and then we're going to divide that by the array length, and that will give us the mean value of the array. Next up, we need to calculate the slope for the linear regression. So to do that, we're going to have a new function called calculate slope, and that is going to take in an x parameter, a y parameter, an x mean parameter, and a y mean parameter. So we're going to create a few variables here. So let numerator, and that's going to be equal to 0. Then we need another one called a denominator, which will also be equal to 0. And then we need to loop through the x values to calculate the x mean and the y mean values. So to do this, we say for let I is equal to 0, I is less than x.length, and then I++. And then we need to calculate the numerator and the denominator. And the numerator is plus equals, and then we have brackets, and inside the brackets we're going to say x and the index of x minus the x mean, and we're going to times that by y and the index, and that's going to be minus y mean. And then to calculate the denominator, we're going to have it equal to plus equals math and the power of x and the index of the x value minus the mean, and the y value is going to be equal to 2. And then once we've done that, we can then return the numerator divided by the denominator. And that should give us our linear slope. So up next, we need to create a function to calculate the y-interceptor. So that's going to be called a function calculate intercept, and that's going to take x mean, y mean, and the slope that we calculated as the parameters. And then this is quite simple. All this is going to do is return y mean minus the slope times by the mean. So up next, we're going to create a function for predict, and that's going to predict the value off of the x value that we provide. So we're going to create a function called predict, and that's going to take in x as a parameter, slope as a parameter, and intercept as a parameter. Then inside this function, we're just going to return slope plus the interceptor times the x value. So return slope plus the intercept times by the x value. And then the last function we need to create is the actual linear regression algorithm. So we create a function called linear regression, and this will take in an x and a y value. So the first thing we need to do in this is calculate the x and the y means. So we create a const x mean is equal to mean and then the x value. And the next one is the const y mean, and that's equal to mean and the y value that we pass in. After we've calculated these, we now need to calculate the slope and the y-intercept. So const slope is equal to calculate slope, and that takes in the x, the y, the x-mean and the y-mean parameters. The next thing we need to calculate is the intercept, and that will calculate the intercept using the x-mean, the y-mean and the slope from here. Once we've done that, we can then map the x values to the prediction, and then it will return the predictions for us. So to do that, we say const predictions is equal to x.map, and then we take in the value that's returned from the map, and then we calculate the predict on the value, the slope, and then the intercept, and that's using this function that we created up here. And then once we've done all this, we can start returning our values. So we're going to return slope, intercept, and then we're going to return the prediction. So that's all the functions that we need to do. So we can actually start running this now. So to do that, we say const slope, intercept, predictions is equal to linear regression x and y. So we're passing these values into this linear regression, which is then going to get the x-mean, the y-mean, and then calculate the slope, the intercept, and the predictions, and then pass that value back into this object here, and we'll have these three values passed as an object. So let's console log this information out. So console.log slope, console log intercept, and then we'll console log out the predictions. So if I hit save on that, then at the bottom here we go node index. Okay, so I'm getting not a number here. I've looked through the code quickly and I can see that I have a capital X here. So let's just replace that with a lowercase x, hit save, and then what we can do, let's run the code again. And we should get our predictions now. So that's great and everything. We have our linear regression with our slope, our intercept, and our predictions based on values that we already have. But what if we want to actually calculate future predictions? So let's create a new function. Let's get rid of these values here and create a new function called future predictions. And that's going to take in the slope, the intercept, a current max value for x, and the number of future predictions. And we're just going to set that to 2 in here. So for these values, the slope will be using this slope value here, the intercept will be using this, and with the current max we'll write out in a second. So inside here we're going to write a constant that is going to be the future values. That's going to be equal to an empty array. And then what we're going to do is we're going to loop over the number of future predictions. So we're going to say for let is equal to 1, I is less than or equal to number of future predictions, I++. Then inside of here, we're going to create a constant called new x, and that's going to be equal to current max plus I. Then we're going to create a new y, and that's going to be equal to the slope plus the intercept times by the new x. And then we're going to push in the new y value into the future values. Once we've done that, we can finish that loop and then just return the future values. So for the current max value, we need to get the maximum value from the x array. So we're going to create a constant called current max. And that's going to be equal to math.max, and then we're going to pass in that array. Then from here we can calculate our future values. And to do that, we call the future predictions, and that's going to take in the slope, the intercept, and the current max. It's not going to take in the future predictions because we've got that automatically set at 2. So let's console log this out, and let's see what we get. So using the linear regression, we have 2.8, 5.2, 7.6, 10, 12.4, and then it goes up to 14.79 and then 17.2. So there you have it. In this video, we looked at linear regressions and how you can predict future values using nothing but vanilla Node.js. No fancy machine learning libraries needed. So whether you're predicting stock prices, student grades, or any other type of data, the principles remain the same. Understanding the core concepts allows you to better appreciate the more complex tools and libraries out there. If you enjoyed this video, don't forget to check out this video on the screen now to learn more about AI. Also, if you haven't already, consider hitting the subscribe button. Thank you for watching, and I'll see you in the next video.